Okay, comrade subscribers, we're a bit of a wet morning again here, but anyway. So I think I might know what's going on. This is the redrawn schematic of the Mikrosha. Come on, can we zoom in? Come on, Mr. Mac. All right, we might have to do it. All right, it's happier doing it this way. Doesn't like doing full screen. But thanks to, I don't know if it says up here, yep, okay. Thanks to Prusak at zxbyte.ru. I think he might be in Belarus actually. Anyway, so the schema electrolytic principal, anyway, for the computer Mikrosha. So if we go down here to the video output stage, so here's the 8275, which is the CRT controller. This is the character ROM here, and this is a shift register, I think, yeah. So basically what we've got here on the CRT controller, we've got the horizontal and vertical retrace, comes down here, and then this is an XOR gate. And then it's inverted, and then we've got an emitter follower here, so a buffer to amplify the signal. And this is combined, so here we've got the output from the character ROM going into the shift register, and so we're outputting bit by bit, I guess, which is inverted, and then it's combined with the horizontal vertical retrace signal to give us the video signal. And then we've got some biasing resistors and things here. And then we've got a pair of capacitors to basically block the DC signal. I think this is where the problem is. So as I keep saying on my board, there's an electrolytic missing, and the ceramic has been just bypassed. So this has been cut out, and this is just straight through. So, like I say, the main purpose of this, as far as I know, is basically to block the DC. We're not blocking the DC component. So I'm going to put these back in. So this circuit here is pretty much the same as the 86RK, even the modern one that Sergey's done. It's pretty much the same. He's got 75 ohms here, obviously to impedance match the TV input. But yeah, this is the problem. I need to put these back in, I think, and then we should get a video. I don't know why they were removed, I guess for whatever TV they were using originally, 40 years ago or something, that was required. But yeah, that's the problem. So let's go put those back in and see what happens. Right, so these two components that I've been pointing at pretty much every video, I think that's the issue. So we zoom in, so video output there, and I think that those two components there are these two here on the video output stage. So at the moment we're outputting DC as well, we're not blocking it. So if we have a look, so video output stage is pin 3 there, yep, and then yep. So I need to put that electrolytic back in and get rid of that bridge there. Definitely keep the capacitor though, because that's got palladium or silver. Never throw away your green Soviet capacitors, even though it's not really worth that much to actually scrap it here. You know, it's still, you know, a bit of history. Don't make them like that anymore, I guess. Right, let's fix that. Turn that on, and what do we need? 10 microfarads and 0.22 microfarads. 200. What's that? What's that? 22. That's 0.022. So I need a 224 Oh yes, I've got 224. That's these ones here, 0.22. Not as fancy as the green ones. And what, 10 microfarads or similar. That's fine. Just before I do anything, if we have a closer look, so that's our 150 ohms to ground, and then there's our 51 ohms. So I'm just wondering whether I should change this to 75 ohms to impedance match. And Sergey on his modern one, rather than having 10 microfarads, he's got 47 microfarads for the electrolytic. So I might put 47 in, and yeah, I'm going to take this fellow out and keep him. So yeah, I wonder if that was replaced at some stage. Anyway, let's get it done. Stop talking about it, Brett, and do it. So I've got them out. So there's modern 22 nanofarad compared to Soviet with palladium or silver in it. I definitely prefer the Soviet ones. much better looking. Anyway, so I'm just going to replace them at the moment. I'm going to leave the 51 ohm in just to see what it does, and then maybe try 75 to see if it's any better if required. I can't get the little insulation ring out for the electrolytic. It's kind of stuck down, so I'm going to have to kind of squeeze the legs in there. Anyway, let's get it done. So 22 nano, and I've just gone for 10 microfarad because I've got a nice tiny one there. Let's see if we can actually get it booted if we get a video signal now. Right, I can say I did get a screen full of characters. So, but again, it's a matter of every time I connect the ground for the oscilloscope, that happens. So if we do this again, so I've just got the oscilloscope connected, just so I can check the. See, that's just connecting ground. Interesting. Obviously, maybe at different potentials or something, but I'm not getting any key click sounds. I'm just checking on the oscilloscope if I'm getting. So there, I'm not getting any activity on the address bus on the 8080. So I need to keep. It's a matter of resetting. I might change that reset button. Because that sounds like a proper reset signal, doesn't it? Like a. Maybe I need to let it warm up. Power off. Power on. Alright, maybe disconnect the oscilloscope. But I did definitely get a video output signal. I imagine this would have driven you insane if this was your machine. Come on. Definitely not working. Ah! Hey, it's working! On the 15th try. Oh, fangula. Try the keys. Yep. So we've got a video signal. It's okay for a 40-year-old machine, I guess. Sorry, let's just get that a bit better like that. Oh, now it's not happy. That was me just trying to press return, I think. Okay. Now, okay, maybe, yeah, now it's maybe at the optimum temperature. It is a bit cooler today. Maybe it needs to warm up. Because now it's kind of reliably resetting. How interesting. Now, I would like to clean up all this other bodge work, but I don't know what it's all there for, and I don't. Yeah, I guess I'm gonna have to sort out the keys now, because se vittu toimi loistavaa, mutta kerro. Is mutta is Finnish or is it Japanese? I can't remember. Kero is Finnish. Mutta I think it might be Finnish, not Japanese. Anyway, irrelevant. So machine works. Looks like it needs to warm up. Maybe. That's the DMA controllers getting a little warm. Nothing's overly warm. That's standard. Not too warm. This is the function cursor keys and stuff. Loistava. Okay. What next? I think the big problem for me at the moment is because the keyboard is integral, so I can't just make a new keyboard and and attach it. Although maybe I could, I don't know. But for example, I know you can actually get, for example, if you buy some, because these key switches are used in various things. If you just buy some junk stuff cheap, then you can recover the key switches. But like for example, this one here is, well, it's working, but it's just coming apart. So I really need to maybe work on these ones. I could probably put all these in. They're working, just without keycaps. Okay, all right, enough excitement. Let's I'm just trying to, there we go, zoom out. Next steps. I can't really use it at the moment because of the way the keys are. So I need to get these key switches sorted. Yeah, I need to work on that next. Okay, I think we'll hold it there for now. So two things. The video output stage now, or should we change? It's not focusing properly. Should we change this 51 for a 75 just to see if we can improve that video output? Let's just try that. Let's just see if we can improve that a little bit, if it makes any difference. Okay, before we make any change to the video output, let's just have a look at the signal as it is at the moment. So, oops. So, okay, so this is the output going to the screen at the moment. So it looks pretty noisy. Let's put the trigger. So that's kind of what it looks like at the moment. I would say that's pretty noisy, isn't it? Let's see, 500 millivolts, that's up 200 millivolts per division. What am I trying to do? What am I trying to do here? Yeah. So okay, so that's the output going to the screen. So that's pretty noisy. I don't know what I can do about that. Let's have a look at the 51 ohms. So this is the output. So 51. This is the output going into the two capacitors. So as you can see there, there's significant. There's obviously a DC component there. That's what we're filtering out. Come on. Okay, so let's move the trigger. Let's move the, okay, I've already had the trigger there. That's 1 volt per division. Let's just move it down. Here we go. Let's move it down. Where's the trigger? Let's move the trigger up there. So you can see there's the kind of character data, I guess. Let's move this along a bit. I would say that's the character data there. And as you can see, there's, we've got this DC component. If we zero it again, it's all the way up there. So that's 51 ohms. Is 75 going to make much difference? Oh, I can give it a try. That's probably the same. That's the 150 ohms. But I just don't know how to clean up that signal anymore. So I've got, like I said, I've got 10 microfarad electrolytic in. Sergey uses a 47. But the main thing is just to filter out the DC. It's doing its job. Yeah. All right. Let's try it. Let's just try replacing that 51 for a 75. It's not, what, 24 ohms. It's not that big a difference. But the whole idea of impedance matching is to avoid reflections of the signal coming back in. So maybe it helps. Right. 75 ohms is in. Come on, focus, man. There we go. 75 ohms is in. Maybe it looks okay. Okay, then it has little spurts like that. Let's check the oscilloscope. Okay, so let's check the 22 nanofarads, which is basically the output of the video. Well, I think it looks a little cleaner. Okay, that's 200 millivolts. That's 1 volt per division. Where is our... Let's go up there. Oh, don't know. It looks a little cleaner, I think. A little bit cleaner. But, like I said, it's only 24, but yeah, it looks a little bit cleaner. The display does, apart from this occasional... Let's wait, what happens when we get that? Oh, you don't see it on the oscilloscope, but yeah, the screen does go a little fuzzy. What about the one, where's the 75 ohm? That's the 75 ohm. Well, I guess, if we're getting a dirty signal in, that's coming out of the, actually that's coming out of the transistor. Maybe I should replace the transistor. Of course, it doesn't really matter. Sorry, hang on. Got DC component there, haven't we? I don't know what the pin out of the transistor is, the Soviet transistor. So if we're getting a dirty signal coming in, what pin is it on the... Oh, I don't have it on here. I'm wondering about the shift register. I'll have to look it up. 1, 2, 3, 4, 5, 6, 7. So that's the horizontal retrace. That's coming out of the... Let me... 1, 2, 3, 4, 5, 6, 7. That's the horizontal retrace coming out of the 8275. And the vertical retrace. Okay, but the character data. Let me just quickly look. Where's the character data coming from? Right, I think I've figured it out. So there's the shift register there. So the character data comes out of pin 16 and then is inverted here and comes out of here. So that's the out. So that's on a pin 10. So into pin 11, out of pin 10. So that's the character data that then gets combined with the horizontal vertical retrace, which comes out of pin 6, I think. And then on the transistor here, this is the emitter because that's connected to 75 ohms, and I think that's the base. Yeah, so that must be the collector. So that's the base because I think it's connected to the 1K. So that's the input to the transistor there, and then that's the output that goes off to the video output. So I'll just have a quick look at the signals there just to see if there's any noise. I don't know. And yeah, then we'll have to figure out the key switches. Alright, so it seems to be behaving. We've got a nice signal on the screen, nice video signal. So let's have a look at the output of the character of the shift array, shift register. So that should be that signal there. Come on. Come on, come on. Hello? Has my oscilloscope crashed? How bizarre. Ah, my oscilloscope, okay. That's embarrassing. It's never happened before. Been quite reliable. I do have to do a firmware upgrade on the Siglant. There is some firmware. Alright. So, as I was saying, there we go, that's the character data there. Ah, my trigger level's way down there. Sorry, I should... Alright. That's 2 volts per division, so that's the character data. Right there. Saying Mikrosha, row by row. And then the rest of the screen is... I wonder if that there is kind of like the... Oh no, that could be the flashing cursor. Yeah, the cursor flashes. Okay, so that's the character output. That looks pretty clean. And then what was I going to check? And then it gets combined with the horizontal and vertical retrace, which I think is pin 6. 1, 2, 3, 4, 5, 6. I think is this one here. That's the output. That looks pretty clean as well. I don't know what that little thing was. What's that? What's that? I don't know what that is. Okay, so apart from that... Sorry. Okay. And then let's have a look at the base of the transistor. I think that's the base. Or is that the collector? Oh, it could be the collector then. Maybe this is the base then. Alright, sorry, the middle one must be collector. Okay, that must be the base. So 2 volt per division. So that looks pretty clean, doesn't it? I think that looks too noisy. Let's move the... I think that looks too bad, does it? So that's the input to the transistor, and then this must be the emitter. So that's the output. Input, output. Let's move the trigger level down. Oh no, sorry, I pressed the wrong thing. Just trying to get the trigger level so it's kind of... It does look a little noisier on the output, doesn't it? That's the output, that's the emitter. That's the input, that's the base. So I don't know, maybe swap the transistor? I don't know. Anyway, there we go. Hopefully that was of some interest. Machine's working. Basically it needs to warm up. Oops. Basically it needs to warm up, and it needs to be reset several times. Let's go down here. So yeah, it needs to warm up, needs to be reset several times, and obviously we need to block the DC current if we want to have any hope of getting a video signal out on a modern screen. So yeah, key switches next. Thanks for sticking around. Hopefully that was of some interest. Bye for now.